after 2 weeks, maybe 3 weeks, then we have so-called midterm exam in the class. So you have to attend this. And I will give you one assignment also after this to see how you improve you, because we didn't do too much. We are trying to enlarge it as much as possible, the theoretical parts, and some applications will be introduced to you. Okay, I'm sharing file, the last part of the unit root, and then go to the Eview.
Hocam,
Yes, please.
just a second. I came to my house. Now, I need 1 minute for attempt the class.
Who is speaking?
Ahmet Dursun.
Ahmet Dursun. Okay, Ahmet. I will wait.
Can I ask something while
Of
we're
course.
waiting? So I would
Sure.
like to ask how it's going to be like our exam, midterm exams. Do we know when our exam is?
We will do in the class. It will be a classical exam in the class. It is requested to do the classes exams, and I don't do any online classes. I don't do any application, because you have to come to the class and we will do the exam, and I will give you next week one application which is going to contribute to your midterm, and then after then I will give you one more for your final. You understand? So exams must be done. So your theoretical contributions, I uploaded already some papers and some videos, some PowerPoints. So you have to study this also for your exam. I will do also, as I said to you, online. I will give you some data to see how you are able to upload the data, do the unit root and some regression analysis. And after then, I will introduce you after this, maybe next week, after your presentations, I will give you the panel data, then introduce you vector error correction applications and in the Eview, and then we'll go through to the ARDL, autoregressive distributions. Okay?
Okay. Also, do we know the date of the exam yet?
Today?
Date, like I know that it will start on 4th, but do we know the exact date of this course's exam?
Yes. During the exam period, we have the exams, but the assignments and the let's say classwork or tests that I'm going to do you next week is also contributive. It will be added to your exam. Okay.
Okay then. Okay.
Hocam, I am ready.
Okay, thank you. Are you able to see the slides?
Yes, sir.
Yes.
Okay, the theoretical distributions and the unit root test we have already introduced to you in the last week. And today we are going to give you some more details about the modeling the unit root, the process, how it is done, and what is the equations, and how is going to affect and change the model. As I said to you, regression is also necessary to do this unit root. When you are doing unit root test, you will determine your method, which method you are going to use, or which test you have to employ for your paper, for your research, isn't it? Due to this reason, I will give you some information about this unit root and how it is going to be. And then after this presentation, I will do some Eview application. As you know, there is either trans-stationary process and difference stationary process. Trans-stationary is the I0, so-called. We are going to determine whether the unit root, when we are employing, is going to satisfy the IO, which means at level, we don't have to take the differentiation of the parameters for making any stationarity and making any probability values, which is going to be less than 0.05. The transstationarity is, as you are observing here, is y is equal to c plus d. The intercept is plus delta t, which is supposed to be stationary when you are doing this unit root. If it is stationary, then the p-value is expected to become less than 0.05. If it is not, then this is then not satisfied. Then we have to take the first differentiation of the parameters, every variable, and then employ the differentiation, so-called stationary process. The delta here, as you know, if you know mathematics, the differentiation means you have to take the difference value between the two, let's say, distance. Let's say y1, yt minus 1, the former period, so-called the last period, will be subtracted from the former period, and you will get this. This is then somehow the lagged estimation, which is giving you the lagged, the periods, which is the different period of time that we are going to employ, then will be then assumed to become stationary. Therefore, we will then employ some tests to do this model and this investigation, or say research, isn't it? Unit root processes are indistinguishable for finite data. In the other words, there are both transstationary process and differentiated stationary process that fit a finite data set arbitrarily as it is estimated. However, the processes are distinguishable when restricted to a particular subclasses of data generating process, such as autoregressive processes, as the p-value, as I mentioned to you, estimated. After fitting a model to a data, a unit root process or unit root test will be then determined. If the autoregressive is at I1 panel data, the coefficient is supposed to be approaching to 1. There are two main reasons to distinguish between these two types of processes. The first is the forecasting and the spurious regression. Unit root, we are employing two hypotheses, H0 and so-called the null hypothesis, and for the H1 or HA is the alternative, supposed to be at HO has the unit root, and HA alternative, so-called the null, has unit root, and the alternative has no unit root processes, as it is given in the below equation. You are going to again take, if it is necessary, take the first differentiation, and will be then represented as alpha plus beta t plus pyt minus 1 plus error term. The ADF, or augmented Digi-Fuller, the serial correlation, can be an issue, in which case the Digi-Fuller test can be used. The Digi-Fuller is handless, bigger and more complex model, which is widely used in most of the, let's say, research. We mostly done this, and then sometimes we are employing others, the Philippe Perron, the Scene, and others. The below are the results from the augmented Digi-Fuller test from two different data sets, one being stochastic or stochastic in nature, the other NACD. The first test, color coded in purple, has a high p-value. As you are observing, it is increasing value, and the test statistic well higher, and the higher critical value is supposed to be, of course, here absolute values. As you know, the critical values must be taken as absolute value, not the negative values. And here it is expected that the critical values, the statistic value must be higher than the test critical values. And if it is, then it is satisfied, or the p-value must be less than 0.05. This means it has a unit root process, and there are a stochastic in nature. We fail to reject the null hypothesis. Vice versa is also acceptable. If it is opposite, then we are going to accept. The test is color coded in green and has a lower p-value. As you are observing, you have some stationarity here and a test statistic well below the lower critical values. And this means it does not have a unit root process and there is non-stochastic in nature. We reject the null hypothesis and accept the alternative, which is desire for the significance. As you are observing, it is becoming significant and it is a belly shaped, some figure is created. The forecasting, a trend stationary process and a differentiated stationary process produce different forecasts. Basically, shocks to a trend stationary process return to the trend line as it is indicated C plus delta T as time increases. In contrast, shocks to differentiated stationary process might be persistent over time. For example, consider the time and the simple trend stationary model which is given to you y 0.9 y1 t minus 1 plus 0.02 t time plus error term. And the different stationary model subtracting yt minus 1, as I mentioned to you in the former slide, from the yt, which is the former period, will be subtracted from the last, or vice versa, taking the differences yt minus 1. The last period will be subtracted from the former period. Then you will get the differentiation as you are understanding in the mathematics we are using continuously. This will then gives you the delta y and is supposed to be alpha plus error term, and then the process become difference stationary as it is given here. Y2 t is equal to 0.2 plus y2 t minus 1 plus error 2, which is in the process. The trend stationary is given here, as you are observing, is a blue line which is somehow increasing, but is somehow linear line, and there's a different stationarity is given somehow again increasing, but is somehow stagnating up and down. And the trend line is, as you are observing, it is a dashed line and it is approaching and almost similar to the trend stationarity. The trend stationary process examines the fitted parameters by passing the estimated model to summarize and find stationary variables. The trend stationary process has confidence intervals that do not grow with time, whereas the differentiated stationary process has confidence intervals that grow. Furthermore, the trend stationary process goes to the trend line quickly, while the differentiated stationary process does not trend towards to the trend line. Y is 0.2 t. This is asymptotically represented for you. The trend stationary is given here, as you are observing. The trend is the dashed linear line. The process is to realize this. The interval estimation process and the forecast horizons is represented with the somehow blue colored on the, I don't know if you see, it is on the right side, which is supposed to be more approaching to the trend stationary. And the different stationary is somehow is a little bit up and down movements is realized. And as you are observing on the right side again, is somehow the dot which representing this difference stationarity. The spurious regression in statistics, a spurious relationship or spurious correlation is a mathematical relationship in which two or more events or variables are associated but not causally related due to either coincidence or the presence of a certain third unseen factor, which referred to as a common response variable. The spurious regression or illegitimate, not true. The presence of unit root can lead to a false interference in regression between time series. Suppose xt and yt are unit root processes with independent increments, such as random walks with drift. xt is equal to c1 plus xt minus 1 plus error term, and for the yt is equal to c2 plus yt minus 1 plus error 2, where error term are independent innovative process regressing y on x results in general in a non-zero regression coefficient and significant coefficient of determination R2. These results hold despite x2 plus yt being independent random walks. Spurious regression. If both processes have trend, then C is not equal to 0. There is a correlation between X and Y because of their linear trends. And however, if the C is equal to 0, the presence of the unit root is then X and Y processes yield to correlation. Therefore, we are trying to realize the first one. The testing the unit root, there are 4 econometric tools test for unit roots. These functions test for the existence of a single unit root. When there are 2 or more unit roots, the results of these tests might not be valid. When we are going to modeling the unit root processes, there are 2 basic models, as I mentioned to you, for economic data with the linear growth characteristics, trend stationarity, y is equal to c plus delta t plus stationary process, and unit root process, also called a differentiated stationary process, which is DSP, is equal to dy equal to delta plus stationary process. Here, the delta is the differentiating operator. Delta y is again yt is the last period of the output minus former period of the output, will then gives you the lag 1 minus L is then t, where the L is the lag operator defined by the L divided to Li is y equal to yt minus 1. The testing the unit root, the transform data, choose the model, determine appropriate lags, and conduct unit root tests as multiple lags. Transforming data, transform your time series to be approximately linear before testing for the unit root. If series has exponentially growth, takes its logarithm. For example, GDP and consumer price typically have exponential growth, so test their logarithms for unit root. Choose model to test. For ADF test or Philippe-Perron test, choose model in as follows. If your data shows a linear trend, set model to trend stationary. If your model shows no trend but seem to have a non-zero mean, set the ARD. If your data shows no trend and seem to have a 0 mean, set model to ARD, the default. The setting appropriate lags depends on the tests you use. The ADF test, as I said to you usually, one method is to begin with a maximum lag, then test down by assessing the significance of the coefficient of the term at maximum lag of P, which is expected. Conducting the unit root, run multiple tests simultaneously by entering a vector of parameters for lags, models, or tests. All vector parameters must have the same length, and the test expands any scalar parameter to the length of a vector parameters. The unit root test, as I mentioned to you, the ADF explanation of the Digi-Fuller test, a simple AR model, autoregressive, can be represented as yt is equal to pyt minus 1 plus u, and where y is the variable interest at the time t, p is the coefficient that defines the unit root, and ut is the noise or can be considered as an error term. And if p is equal to 1, the unit root is present and in a time series, and the time series is non-stationary. In the ADF, the regression model can be represented as delta y or yt minus 1, last period of y minus former period of y, will be equal to p minus 1 yt minus 1 plus ut, or delta y t minus 1 plus ut. Delta is the difference operator and delta is the p minus 1. And so here, if P is 1, which means we will get the differencing as the error term. And if the coefficient has some value smaller than 1 or bigger than 1, we will see the changes according to the past observation. There are 3 versions of the test: testing for the unit root, test for the unit root with constant, and test for the unit root as constant and deterministic trend, which we are usually using test constant and deterministic trend with time. So if the time series is non-stationary, it will then tend to return an error term or a deterministic trend with the time values. If the series is stationary, then it will tend to return only an error term or deterministic trend. In a stationary time series, a large values tend to be followed by a small value, and a small value tends to be followed by a large value. And in a non-stationary time series, the large and the small value will occur when probabilities that do not depend on the current value of the time series. The augmented Digi-Fuller test is an extension of the Digi-Fuller test, which removes autocorrelation from the series and then tests similar to the procedure of the Digi-Fuller test. The augmented Digi-Fuller test works on the statistics, which gives a negative number, and rejection of the hypothesis depends on the negative numbers, and the more negative magnitude of the number represents the confidence of presence of unit root at some values in the time series. We apply the ADF on a model, and it can be represented mathematically as delta y. T is equal to alpha plus beta 2 plus gamma yt minus plus delta 1 delta yt minus 1 plus it goes like this to the error term, where alpha is the constant, n is the question where is the coefficients, and p is the log order of the autoregressive processes. And here is the mathematical representation of the ADF. We have added the differencing terms that make changes between ADF and the Digi-Fuller test. The unit root test is then carried out under the null hypothesis, which is supposed to be 0, against the alternative hypothesis which is supposed to be less than 0. Once a value for the test statistic obtained, then in statistics, a unit root test whether a time series variable is non-stationary and possesses a unit root. The null hypothesis is generally defined as the presence of a unit root, and the alternative is either stationary and transstationary or explosive root depending on the test used. A key point to remember here is, since the null hypothesis assumes the presence of the unit root, it can be compared to the relevant critical values for the Digi-Fuller test. The test has a specific distribution simply known as the Digi-Fuller table for critical values. The probability value obtained by the test should be less than significance level, as I said to you, less than 0.05. The null hypothesis will be then rejected. Therefore, the interfering the time series is stationary. The implementation of the ADF test is then to perform the ADF test in any time series package. Stats model provides the implementation function and Fuller, and functions and Fuller provides the following information: the p-value, which is less than 0.05, value, the test statistics that is expected to be, if I am going to introduce you in the following chapter and following application, you will understand the numbers of the log for the testing consideration, and the critical values, which is said to the test statistic must be higher than this for becoming reliable. Next, in the following, we perform the unit root test and interpretation. Autocorrelation. Just as correlation measures the extent of linear relationship between two variables, autocorrelation measures the linear relationship between logged values of the time series. Autocorrelation means that the linear model is self-aware. It is constantly taking into account a past version of itself. A time lag is when the model measures its current performance in comparison to the past performance after a given set of time. And this is yet another way of measuring the stationarity of the model. It is a simpler approach than trying to color code your graphs based on the outcome of the ADF Fuller results. As it is given here below in the correlogram for Google Stocks over a period of 5 years is interpreted. The lines being extremely close to 1 and in a slightly descending visual pattern indicates the amount of the autocorrelation. As you are observing here, the values where it is represented with blue has the autocorrelation, the descending values, the descending or colors, the graphic. Looking at the second choreogram below, we can see that autocorrelation is very low and random, meaning our model is stable. As you're observing here, then we have, if there is a big up and down movements, this is not stable and there is some problem with this. Usually choreogram starts with the first lag being fully correlated with itself at 1. And as you observe here, the closer to 0 each lag lies, the less autocorrelation present in the model. As you are observing here, after tens is going to be more realistic and more reliable where the autocorrelation presents. Differentiating is a technique that can be applied to a data set in order to remove any sort of stochastic. It is a method to make a non-stationary time series stationary. We are computing the difference between consecutive observations, and this is a technique applied after a unit root test and autocorrelation tests have been performed. As you're observing here, the differentiated is given. As much as these lines going up and down, there is some problems. There's a breaks, and this is must be corrected before performing your estimations. You have to add some error terms to correct these breaks. Okay, this was the unit root. As much as briefly introduced to you. Now I'm going to give you the Eview. Do you have any question?
No, sir.
Okay then. I will then upload now the Eview 10 and start to show you how we are doing it. I will get two variables, one dependent, one independent, and then give you one example which is done, okay? Because we don't have time to do all. Then I will show you how we are going to do, okay? Okay, I will quit this PowerPoints and then upload Eview. If you are seeing Eview, let me know. The Eview is already on, isn't it?
No, hocam.
No. Okay, then I will then quit this presentation and share you the Eview. Let me see. I don't know why it doesn't come. Let me open it.
Something has started, sir, saying whiteboard is coming. Processing.
I know. I will open first Excel to upload data. Let me open first. Well, if I'm going to open Excel and then I have to quit and then upload this and quit, and because I thought the screen when it is shown, then you will follow my window, but I have to quit every time, I think, isn't it? Because otherwise it will not work. This we cannot do anything. Let me check if I am able to upload this Eview. I tried last time, it was working, but now. The Eview is not here, I don't know why. Let me open one window. Let me check that one. The Eview is not here, I don't know why. Ah, okay. Now, you have the Eview, isn't it? You got the Eview here?
Yes, sir.
Yes, sir.
Okay. Okay, I'm opening. I thought I can upload from Excel, but it is not allowed, I think, to change because when I'm reflecting this, sharing my screen with Eview, then I have to quit Eview and then bring the Excel. It is complicated, and I'm going to open any data. Then I will explain. Okay.
Okay, sir.
Okay. Let's open this one. Okay. You want to know how we are going to upload data, isn't it? First, we have to go to the view and open a work file. You will go to view, open a work file, and then you will upload. But if you have opened already, we have done this, then you want to upload some data here. You're going to click the new object here. Then you put here the series and name this, for example, let's say we have GDP here. Let's say NX. Click OK. Then you have here NX. Then when you click on it, you have to upload from Excel your data. You copy paste and upload here. You understand? Is it clear? Then we have this. When we are doing this, after uploading the data, then we want to make sure our variables are stationary. For doing any test, we want to test for the unit root whether the variables or parameters that we have, it is stationary at level or we need to transform it to the first difference. Then we click on, actually this, yes please.
You don't set any time here after uploading the data.
There is no need. Time, yes, you upload. You have to fix when you are creating objects here. let's say we have here nx. You can fix it because I have here the certain data. When you can upload it, you can. I will make it one new object. You set nxt. When you are having this, then it is okay, but you have to upload the data with the limit. When you are clicking this nxt, then you will then put the set, because this is already done. I can show it here because, as I said to you, I have already done this with the limitation, but you will have the data when you are going to open the work file. As I said to you, this is done because I don't have the data here to upload from Excel, because I have to create from Eview. Then you will upload it and restrict, let's 9070 to 2000, or 9080 to 2000, or 2000 to 2020. Then it is okay. This is not difficult. I quit this. No, I said file, new, work file. Okay, now you see here the start and end. You got it? But I don't have data here. Therefore, I cannot. You understand, Ali? You put
Yes,
here
sir.
8. Okay, you got it. And if it is annual, then you will then put an annual. But I have open already uploaded data. Therefore, I cannot do this. This is. Is it clear? If it is annual, then you annual. If it is quarterly, the same you done. Then you click OK. Then it is coming.
But we
It's
have
clear.
to do it for each data, yes?
You will do this first.
Once
then
or
you
for
have.
each data?
You will do this first, and it is going to be on the same period. You
Okay,
then need to repeat it many times.
Okay, sir.
We cancel it. Then we open it again with our work file. I don't know, my system is not required, maybe older version, because every new version of Eview is reducing this, things that you are doing many times. It is improving. Therefore, I don't know which version you have. I didn't try the student version. Okay, I'm opening this. I'm opening this, and we are going to click on it to test the unit root. We go here, we go view, then you come unit root, and there is options: augmented Digifuller, Philip Perron, Kawasaki, Elliott, Rothenberg. We choose ADF. Click OK. At level, we are going to test for the I0, isn't it? And intercept. Then we click on, then it comes, and we should look here. It is satisfied already because I employed the regression here, and there is no problem here because it is satisfied. As you're observing, it is good because at 5 level, it is satisfied. The T statistics also, and probability is 0.01. Then you have no problem with this parameter, with this variable. Is it clear? Then we go to the other one. You click again. You are following. If you have question, you ask me. Then we do again. We look. When you're uploading this, this is also satisfied. There is I0 level is satisfied. I don't know if you are following, and if you have any problem, you ask me, then I will repeat it. Is there anything to ask me? Is it clear?
Sir, if you explain it, the coefficient, standard error, or T statistic, or probability, all of them, then if you have explain it in here, that will be so good to understanding.
I explained in the theoretical part, but I said if this 0.05, it is less than 0.05. Therefore, it is satisfied. Please don't speak. I don't. I already explained this. Zero you here for the unit root, you have to look only the T statistic and probability. You understand?
Yes, sir. I understand. Only for the clarify that I have to know that
Probability
is
value.
there
Listen. Okay, who is speaking? Okay.
Zikrullah.
Probability. Okay, Zikrullah. Probability value must be less than 0.05 for employing. This is stationarity, significance. And
Okay.
T statistic
Yes.
must be higher than test critical value. As you are seeing, it is
Critical.
higher. Okay, then it's no problem for
Okay.
the 5% and 10%. Is then okay? You can do for the other one, the PCI, per capita income. We are going to employ the unit root. We are looking again. Is also no problem. As you see, it is again the absolute value for the T statistic is again higher than the test critical values, and the probability values is less than 0.05. There is no problem with our variables, isn't it? You got it. And then let's look manufacturing value added. Again, unit root. If you are not understanding, I can repeat it. Therefore, we tried for the intercept. Then we click OK. And as you see, again, 0 probability. And again, the test critical value is higher than the statistic value is higher than the test critical values, as you observe for the 1%, 5%, and 10%. There for the absolute values, of course. Then we can go for the regression or OLS, so-called the simple OLS we can do. But let's look up to the deterministic also. Unit root, we are going to make trend and intercept deterministic. Then you're gonna employ it again. Then you look again satisfied. Probability value is 0. Test statistic value is higher than test critical values. Then it's fine. They go next. Click, open, unit root, intercept is okay. Again, you see, it's nice parameters. You're going unit root. Okay, it's fine. For per capita income, again, it's fine. You see, no problem. Then you can employ. Now, since all parameters in at level in I0, then you can perform regression, OLS, or ordinary least square, isn't it? Then if you want to do this, then you have to go to the quick estimate equation. You have to write the explanatory, or so-called the dependent variable, and then independent. We have here the PCI as dependent. Then you perform for this, then C, then other parameters I will employ. Value added agriculture. And one more we have. You are following. If you have question, you ask me. Do you have any question?
No.
Are you able to follow? Is any problem with
Let's
this?
say they were. Hocam,
If
may I ask something?
Yes, please.
Let's say these are all okay stationary at the level. But
Yeah.
what if it was in the first difference? We had to do some other test, yes, for the
Then yes,
co-integration.
okay. This we don't have to run too quickly. Let's do this because, of course, if it is mixed, then you will do ARDL, for example, autoregressive distribution. If it is
What if they are all level?
I0, if it is I1, then you will do vector error, isn't it? Vector error, either restricted or unrestricted. It is depending which test. But let's go step by step. I don't want to go faster because we have to do every time. Sorry, we have to
I'm just asking this for something else as well, sir. I'm very, very sorry. Just one more question that I'm not going to ask something further. But the co-integration does not depend on unit roots. The co-integration test you do, does it depend on the unit roots or it doesn't?
No, you have to do first to see whether it is then. There is then co-integration is also important for checking your stationarity. You have to do either or. It depends.
Okay, sir.
Then we are going to click OK here. This is for OLS. Do you want me to show you the first difference, how you are going to do? The first difference you need to see before going this. I think it's better. You want me to show you the first difference? How we are doing the first difference? Do you need?
Yes.
Shall we do all? You agree?
Yes,
we
can do it.
Let's think which one we can do. Let's think. I can open another data to show you, okay? Because we have here all in the level. Or I can show you just in case how we are employing, because it will be the problem. We open this, but if this is as you see, if the unit root is not satisfied here, if this is not satisfied, there is here 0.5, for example, of the 0.6 something. Then we have to do some. We have to employ something to change first difference. Then we will go to quick first, but you have to add new object. You write here D. For example, let's do for value added agriculture. Value added agriculture. First, you have to define it, isn't it? You click on, then you go to quick, then go to general series, then right here is anything. The value added agriculture is equal to D in bracket value added agriculture. Then click OK. Then this will create it. You see, this is then the first differentiation. Then you go here again and do the unit root. That's how it is going to be. Is it clear?
Yes.
Do you have any question? Okay, okay, we're going to quick estimate equation. Then going to PCI. C. Trade. And manufacturing value added. Click OK. Then we have the table here. Now the problem here to interpret here, as you see, we have some variables here. For the results for interpreting, as you are observing, when you are looking to the probabilities again, it is satisfying. Then we have to go to the results for the standard error. When we are looking, the standard error is the coefficient indicates the accuracy of the estimated OLS coefficients with respect to its population parameter. And the coefficients, as you are observing here, is the signs of the direction of the relations. As you are observing here, we have positive. Do you have any question?
Hocam, I didn't
Yes,
understand
no,
the
sir.
standard error and coefficient relationship.
When you are going to go to the t statistic, coefficients will be divided to the standard error, and this will then give you this t statistics. T statistics becomes more realistic. The standard error is the coefficient which indicates the accuracy of the estimated OLSU regression. It is, of course, the coefficient with respect to its population parameter, as I mentioned to you in the theoretical part. And the coefficient science is the direction, shows the relationship or the direction of the parameters which affects each other. Therefore, here the coefficients which is positive means there is a positive relationship between the dependent and independent variables. And when you are going to the t statistics, is it clear now? When you go to the t statistics, it is then used to test the linearity of the relationship between response variable and the predictor variables. So precisely, if I'm going to define it or explain it, it is used to determine whether or not there is a linear correlation between the response and predictor variables. Is it clear? Yeah, I mean,
Yes, sir.
T statistics is the division is going to be get from the coefficients. When you're going to divide the coefficients to the standard error, you will get the T statistics. You got it?
Yes, sir.
Hocam,
Yes.
so
This
the
will then
T statistics should be high as possible, as high as possible, or as low as possible.
it is depending to the estimation. T statistics, it shows the relationship. If the T statistics helps to predict the linear relationship, it's statistically significant. It is, of course, expected to become reliable for this estimation. It is depending to these coefficients. If it is higher, it is approaching. As much as the coefficients increasing, this shows the impact to the parameters, how it is affecting and changing it. It is a prediction for the linear relationship. And the probability values must be between 0 or 0.05 for the significance. Is it clear?
Yes, sir.
When we are going to down, the R-square shows the as much as it is higher is better, and if it is lower, then it is not good. It is expected to become somehow 60% and more for becoming a reliable estimation. As much as it is high, this is good for the R-square. This means dependent variable will be explained by the explanatory variables sufficiently. When we go to the adjusted R-square, this is then increase or decrease the independent variables. And as I mentioned to you, too much explanatory variable in the equation, if it is more than 3, which is usually not desired, maybe 4, this will then cause some negative signs for the adjusted R-square. The F statistics shows the significance of the explanatory variable, which affects the dependent variable. These are all necessary to explain when you are having this. Here, the F statistics must be higher. As much as it is higher, will be then better for the estimation. Better model is supposed to be realized. Any question? The others, the Akaike, Schwarz, info, criterion, these are all used to choose the best model, as I said to you. If the Durbin-Watson here, for example, is less than 2, it is the evidence of positive serial correlation. If it is less than 2, it shows this relation. If it is higher, then it shows a negative relationship. And multiple regression analysis is also introduced in the following. Do you have any question? This is the simplest estimation of the regression analysis. Any question?
Hocam, can we do one for the level as well? One correlation for the level.
One correlation for the level.
Yes, when they are stationary at level. First difference.
I have to quit, and you mean the first differentiation, not level.
Yes, sir, I'm sorry.
Because we have done already. This is level. You want first differentiation. I have to quit this.
Yes, please, sir.
When I am quitting this, then I have to do mix something. We can do mix something. I have panel data, but I don't want to do this. I will do something easy, simple something. Let's do Turkey. We can do many. You can do quantile regression here. You can do many, but let's stay here only for the OLS. Of course, we are not able to employ OLS here because it is mixed, as I said. Can do this. Let's do this. Okay. I don't have here all because I have the first difference. All let's look other one. This is all first difference. I have to show you the first level, then the first. You are following the screen?
Yes, sir.
Yes, sir.
Let's try Cyprus. Okay. This is a little bit too much, but let's look up employment. For example, here we are going to make the unit root. Let's intercept only. You see here we have problem because it is not significant. As you see, the t statistic is also not satisfied. So you're asking me about the t statistic. It must be higher, isn't it, for satisfying? It must be higher than the critical values, not higher. You were asking me the t statistic about, isn't it? Because it is depending to the test critical values for the t statistic. It is not necessary to get too high, but it must be higher than the let's say 1%, 5%, and 10%. It must be. It is better if it is higher than all. You understand, İlker? Therefore, it cannot be justified if it is too high. It is good. It must be higher than the test critical values. Is it clear for you? This part, you got it. You understand, İlker, Ali?
Yes, sir.
This shows you this is, for example, not satisfying, isn't it? Because it is negative. It is less than 10%, 5%, and 1%. Therefore, it is not good. And the probability value is also not satisfying. As you see, it is higher than the 0.05. Then we have to employ I1, the first difference. And here I have already done the, you got it, how we are doing the parameter, how we are changing the variables to the first difference. Did you get it? You have to click here, new object, and you write here, as I have written here, the emp. You see the emp employment. Then you have here the emp, and then for the first differentiation, you have to go to the quick and then write this d is equal to, I have shown to you. Therefore, this will then help you for satisfying the first difference. Then you go to quick, then you go to general series. Then you write here the amp is equal to the amp, isn't it? Then when you click OK, this will then brings you the first difference of the variables anyway, but I have already done. Then you click for the employment, then go to view, unit root. Let's check. It is, but you have to take the first difference. You have to take the first difference because we are using the first difference. Intercept first. It is satisfied, as you see, and the t statistic is higher. As I said to you, it depends. If this is here only up to 2, then you have maybe 3 is then t statistic is satisfied. You understand the way. And then go to unit root again, do the trend and intercept. Then you have again, then this is satisfied. Then you will put this data to your test and show why you are using this for your vector error correction, for example. Because when all parameters or all variables are in I1, then you have to employ some other tests, some other methods. Here we cannot employ OLS, isn't it? Because OLS is only done when all parameters are in I0 at level, satisfied. Do you have any question? Because I don't want to do all, but if you don't understand, I can go through once again, or I can explain it once again to you, then finish it. Do you have any problem with this? I think this is satisfying you, because next lecture, you will do this. I will give you some data, or you will bring me your data, then we will do it. Because, or I will, if I'm going to upload, you will not able to do. Therefore, you have to employ your Eview, then show me how you are doing. Every person will do one example for me. Two variables, one dependent, explanatory, independent, and then we will see how it is going to affect and change the model. Is it clear? Do you have any question, please?
Hocam?
Yes, please.
Next week, are we going to gather the data, or you will give us and we will do it? I didn't understand that.
I will give you data. I will shall I have to send to the group, or shall I have to send you a bulk mail that you will distribute your data, or you can employ any data for me, but not your own example if you did for somebody else. I can give you the data to see how you are going to perform it. It is no problem. You can upload your data also and do it. I think it's not be a big issue, I think, isn't it?
Yes, thank you.
Do you have any question for this presentation? Or if you don't understand, I can go through again, or I can repeat some parts. Or if you have any question, what is these parameters, what means R square or blah, blah, I can explain it. I think Eview is better than Stata. I think some students using Stata. Eview is very compact program, and everything is inside, and it is very simplified way for people who are doing very comprehensive, very complicated research. Therefore, this will help you and faster you for doing your tests easily. I don't know. I don't use too much Strata. I use some, but I didn't like it because it is not very. But I mean, I prefer Eview. It's better for me. I don't know. Some people maybe do it in Strata, but Eview is for the economics professors and students. Is better for you business estimations. Do you have any question? Do you want me to explain any parts or anything that you don't understand? Because we will not go back. We will go after then the panel data. Then I will do some estimations and show you how it is going to be. I will do some Hausmann tests, some other tests, some correlation, some Granger of causality tests, which are all in the program, but important thing, as I said to you, to interpret this data. As I mentioned to you, the interpretation here, as you see, the R square here is 0.882, which is 82% very high and very good for our, but as you see here, the second and the others are not, but the first difference is satisfying. Yeah, you will interpret and explain your model, why you are using this and why it is you employed. If you don't have any question, then I will quit. Do you have any question? If you have any question or any problem with this, because this is the first time maybe for some people, I don't know, I can explain it. Do you like it? Do you like this program? Who don't use this? Do you think it is easy for you or it is difficult? If it is difficult, then tell me which part is difficult for you, then I will explain it once again.
Hocam, I think Stata is much easier.
Much easier. This is difficult for you. This is difficult.
It's more complicated, Hocam.
Is it? Which part, for example?
For example, when you do the first difference, in Stata, you just write d dot at the beginning of the variable. You don't need to do anything else at all.
But what if we did only, we employ only, we click right mouse and new object and add only dm, for example, and click OK, isn't it? And then you go to quick. Is it difficult for you? This.
Hocam, in Stata,
when you go to quick, I know
there's a timeline, and that timeline helps me a lot to go back and see every time. For example, you are doing the tests and you want to go back to see what you have done 2-3 steps before. You just at the left hand side, you just scroll it up, or from the left hand side, you choose your X command, and it goes straight back to that.
Well, thank you for your comments, but are you thinking all the same? This is difficult. Eview is difficult. For me, it's not difficult, but maybe for you it's difficult. And tell me which part is difficult for you. If it is difficult, then, or did you get any comprehensive explanation for this, or do you have any problem with this? Do you have any idea, or do you need any explanation for this? Other students? Ali says it is difficult for me, or it's not, it's complicated, but I don't know, I don't think so. Do you have any problem with this performance? Do you think it is easy or difficult to do, use Eview?
I don't have enough experience to,
so it becomes difficult.
Compare.
So when you are repeating, then you will learn by time.
Yes.
I know, yes, I know everything. When you are starting, it is difficult, but that's the reason I will give you time. Try to use this next week. We will do together, and I will direct you where you are making mistake. I will tell you, don't do this, do this, then you will then learn step by step. When we are repeating this, then you will learn. Everybody will then learn better, probably, because I do it quickly, because we have a limited time. Approximately 2 hours we spend it on the presentation and this application. Therefore, we don't have too much time to go very slowly and step by step to do everything and then catch up the program. But it is, believe me, very comprehensive when you are doing complicated issues, when you are doing too much businesses and too much tests and applications. This will help you. Well, it depends. We don't force everybody to do this, but this is how it is done. If you don't have any question, I will quit. You have anything else to ask me, or do you want me to finish? If you have any question.
So far, it's good, sir. It just needs some practice alone. That's it.
Okay, then you can watch this video also. I will upload this video to the YouTube, because in this system it is not allowed to let it for a longer time, maybe 20 days, I think, or 25 days, or maybe 1 month. But in YouTube, I have one channel that I upload my old lessons, because students always want to repeat and watch and see and learn some parts. Then you can watch these videos on YouTube also. Then this will then help you to go step by, you can stop and go step by step and learn it comprehensively. I think This is the easiest way because other option is not possible. We cannot repeat these lessons many times. Okay, then thank you very much for you joining. See you then next week with your performance. I will upload some data, then you will do it by yourself. Okay, if you want, I can send you, tell me you want data, then I will give you data, then we can do together. I will give you one explanatory, one GDP and let's say export, or GDP and let's say employment, or GDP and interest rate. We can do something, then see how it is going to perform, how it is going to be resulted. Okay. Thank you very much.
Sir.
See you then next week. If you want data, then let me know, then I will upload for you. Thank you. Bye-bye.
Thank you.